50 concurrent Docker builds just crashed your daemon, 12 GB of RAM gone, and it hung for 20 minutes. Here's exactly why. Welcome to TheCodeForge. Before we dig into that production issue, let's cover Docker architecture explained. Docker uses a layered client-server architecture. The CLI sends HTTP requests to the daemon, which manages images and containers. The daemon delegates low-level operations to containered and runc, which interact with the Linux kernel. This design centralizes control but creates a single point of failure. Let's look at each component. The CLI is just a thin client. You can replace it with curl. The daemon handles the API and image building. Containered manages the container lifecycle, and runc actually creates the container by calling kernel syscalls like clone and pivotroot. Here's how to trace the component chain. The CLI talks to the daemon via a Unix socket. Containered runs as a separate process, and runc manages containers at the lowest level. You can inspect each layer with these commands. When you run Docker build, the CLI tars the build context and sends it to the daemon. The daemon parses the Docker file and executes each instruction sequentially, checking the cache first. A cache miss triggers execution, and a new layer is committed. Use BuildKit with progress equals plain to see every step. Count cached versus executed steps with grep. Then inspect layer sizes with Docker history to see which instructions contribute the most to image size. Images are distributed as layers identified by SHA-256 digests. The registry deduplicates layers. If two images share a base layer, it's stored once. When pulling a new version, only changed layers are downloaded. But Docker Hub limits pulls per IP, which can hit CI pipelines hard. Save an image and extract its manifest. The manifest lists layers in order and points to the image config. The config contains runtime settings like env-vars and enterpoint. This is the actual structure of a Docker image. When you run Docker run, the CLI sends a request to the daemon, which delegates to containered. Containered generates an OCI runtime spec and invokes runc. Runc creates namespaces with clone, changes the root with pivotroot, and starts the application with execv. Create a container without starting it, then start it and find its PID. Inspect the OCI runtime spec in containered state directory. This config, JSON, defines all the namespaces, mounts, and the process to run. Docker's storage uses overlay 2 to stack read-only image layers with a per container writable layer. Multiple containers from the same image share the read-only layers. This is why starting a second container is instant. Volumes bypass overlay 2 entirely and go directly to the host file system. Check the storage driver with Docker info. List the overlay 2 directories, each is a layer. Inspect an image's layers and a container's graph driver data to see the merged, upper, and lower directories. Docker networking uses a Linux bridge called docker0. Each container gets a veth pair, one end inside the container, the other attached to the bridge. Iptables rules handle port publishing and outbound NAT. The default bridge lacks DNS, so always use user-defined networks for production. Check the docker0 bridge IP. Create a container and inspect its eth0 interface. Note the veth pair index. On the host, find the other end of the veth pair attached to docker0. List the iptables NAT rules Docker added for port publishing. This is the same issue we highlighted at the start. Here's exactly why that happened. The daemon processes all builds through a single event loop. With 50 concurrent builds, the daemon's goroutine count spiked to 10K+, file descriptors were exhausted, and overlay 2 lock contention on the layer cache caused exponential latency. The daemon stopped accepting new connections, freezing all operations. The fix involves limiting concurrent builds per host to 4 or fewer, using Docker and Docker per build, or switching to BuildKit with remote builders. BuildKit parallelizes independent build steps, reducing lock contention. The key change is setting Docker BuildKit equals 1 to enable parallel execution. Running 50 concurrent builds on a single Docker daemon is the exact mistake from our hook. Each build consumes daemon resources linearly, file descriptors, memory, and lock contention on overlay 2. The daemon's single-threaded event loop cannot handle this load, causing a complete freeze. Overlay 2 has a copy-up penalty. The first time you modify a file from a lower layer, it must be copied to the writable layer. For multi-GB database files, this can cause seconds of latency. Always use volumes for databases to bypass overlay 2. A missing dockerignore can send 500 MB or more of unnecessary files to the daemon, including node modules and Git. This causes the build to hang at sending build context for minutes. Always add a dockerignore with at least node modules, Git, and log. Docker Hub's pull rate limit is per IP, not per user. A CI server behind a NAT gateway with 50 engineers can hit the 100 pull limit in minutes. Always authenticate CI runners with Docker login to double the limit to 200 or use a pull-through cache. If you flush iptables while containers are running, Docker's DNAT rules for port publishing are removed. Containers become unreachable from the host. Restart Docker to recreate the rules or avoid flushing iptables on Docker hosts. The article shows Docker BuildKit equals 1 to enable BuildKit. As of Docker Engine 23+, BuildKit is the default builder. On older versions, pre-23.0, the legacy builder is still default. Always check Docker version to know which builder is active. The article mentions the OCI runtime spec, but doesn't show how to inspect it for a running container. Use runc spec to generate a default spec, or find the container's config JSON under containered state directory. The article notes that iptables F breaks port publishing. In production, third-party firewall tools like UFWA or Firewalled can also interfere with Docker's iptables rules. To prevent this, configure Firewalled to ignore the Docker bridge, or set iptables equals false in Dockerd and manage rules manually. To diagnose daemon issues, start by checking if the daemon is active. Use pstree to see the process tree and count file descriptors. Check build cache disk usage with Docker Builder do. Finally, check kernel logs with dmesc for cgroup or namespace errors. Let's run through some common interview questions. What is the role of Concurrent? Manages container lifecycle, image pulling, and snapshot management. Extracted from Docker in 2017. How does Docker achieve layer sharing? Multiple containers from the same image share read-only overlay 2 layers. Each container has its own writable layer. Why is the Docker daemon a single point of failure? All CLI commands funnel through one daemon process. If it crashes, all operations fail. And a few frequently asked questions. What is the OCI spec? Standardizes image format and runtime behavior, enabling runtime replaceability. How do I fix cannot connect to the Docker daemon? Check if Dockerd is running. Verify the socket exists at /var/run/docker sock. Should I use volumes or bind mounts for databases? Volumes, because they bypass overlay 2 and provide better performance and data persistence. To recap, Docker's architecture is a layered client-server model. The daemon is a single point of failure, so limit concurrent builds. Understand overlay 2 for storage and use volumes for databases. Always use user-defined networks for DNS resolution. Monitor daemon health under load. Ready to go deeper? Up next, Docker images and containers, then Dockerfile explained, then Docker volumes and networking. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.